Okay. All right, so like I said, we were venturing out of triangles and into quadrilaterals.
Ooh, moving up in the world.
Yeah, moving up in the world. So quadrilaterals. Before we get really specific with quadrilaterals, though, we are going to refresh ourselves on polygons. Okay? So the main part of this chapter will be on quadrilaterals. We will mostly deal with figures with four sides. But for the first section, we're going to deal with figures of all sides. So we need to refresh ourselves with their names. And then we are also going to talk about angle measures in these. Okay. So, a triangle has three sides, right? In a triangle, there is only one triangle, right? There's no way. That's our option. It just forms one triangle. How many degrees are there in a triangle? So the sum of the measures of a triangle is 1 times 180, so we get 180 degrees. So if we add the three angles up, we know it's 180. Now a quadrilateral has four sides. How come a quadrilateral says two triangles? Yeah, we can split it in half with that diagonal. So there are two triangles in a quadrilateral. Each of these triangles has 180 degrees. So to get the sum of the angles, we would take 2 times 180, which gives us 360. Okay, so every quadrilateral has 360 degrees. Pentagon. Three triangles, you're saying? Why? Okay, so I could go straight across and make this one, and then I have a quadrilateral left. So I could go diagonally and make that one. So here I can split this up into three triangles, which means I would do 3 times 180, yep. Oh, I'm hearing two different answers. I'm hearing 540 and 520. It's 540 degrees, yep. Okay. A hexagon, which has 6 sides. Oh, I started drawing a pentagon. Try again. Well, first off, here's a hexagon. I could split it in half right away, right? So I could go in half. And now I have 2 quadrilaterals. So each quadrilateral we could then split. So there are 4. Okay, so to find the sum of the measures, what would we do? 4 times 180. You sounded hesitant about that. Okay. Are we seeing a pattern here? Yes, we're seeing a pattern. So the number of sides, how do we relate the number of sides to the number of triangles? It's 2 less. Okay? So if we have a heptagon, which is 7 sides, how many triangles? We would do 5 triangles. If we have an octagon, which has 8 sides, we would do 6 triangles. So to find the sum of the measures, here I would take 5 times 180, which is 900 degrees. For an octagon, I would take 6 times 180 at 1,080 degrees. Okay, now there's got to be an easier way to find this than creating a chart and finding a pattern. Okay, so there's actually a formula that we can use to help us find the sum of the interior measures. And it's the interior angle sum theorem. So it says if we have a convex polygon, so refresher, what does a convex polygon mean? No caves, no indents. So a convex polygon, it has n sides and S is the number of measures of its interior angles. Here's your formula. S, so the sum of the interior angles is equal to 180 times n minus 2. Well, why would this be n minus 2? N stands for number of sides. Minus 2, right, because that's how we would figure out how many triangles there are in the diagram. So we would take that value and times it by 180. So if I tell you we have a 56gon, we could easily find the sum of the angles just by taking 180 times 56 minus 2, or 54. Okay, so that's going to be our formula for the sum of the angles. And then there's one other theorem we need to talk about today, and that is the exterior angle sum theorem. Exterior angle, where do you think those would happen?
The outside.
The outside. So, for example, see, I'll draw a pentagon because I'm best at drawing pentagons. Pentagons, if I took this, I would extend each line like this, and I would have 5 exterior angles. Okay, so those would be our exterior angles. What our sum of exterior angles theorem tells us is that if we have a convex polygon, so once again, no caves, no indents, the sum of the measures of the exterior angle is 360 degrees, no matter what. So whether we have a quadrilateral, a triangle, a pentagon, a heptagon, a dodecagon, it's always 360 degrees every time. A very easy one to see this on would be a quadrilateral. So this quadrilateral here, I'm just going to extend these. And let's say that this is a rectangle, so each of these is 90. What do each exterior angle have to be then? 90. So 90 plus 90 plus 90 plus 90 is 360. Okay? On a triangle, if you extend these two angles would have to add to give you 180, right? These two would have to add to give you 180, and those two would have to add to give you 180. So I don't know. If this were, let's make this a 30, 60, 90. If this were 30 degrees, this other one would have to be 150. If this were 90, that'd have to be 90. If this were 60, that'd have to be 120. So if we took 150, 120, and 90, we would get 360. So it doesn't matter how many sides we have, exterior angles are always 360. Guaranteed question on a quiz and a test. Most of the time, half the people get it wrong. So you try to do some fancy formula. No need, just 360. So let's try putting this to some uses here. Purple? Purple it is. Find the sum of the interior angles of a 21-gon. So we're going to use our sum formula. So sum is equal to 180 times n minus 2. Okay, so we have 180 times 21 minus 2. Well, what's 21 minus 2? Let's try 19. So 180 times 19, what does that give us?
Hold that thought. 3,420.
So the sum of the interior angles of a 21-gon is 3,420.
I'm so lost. How do you, why is it so big?
That's this big.
Well, it's a 21-gon. I mean, that's got a lot of sides, right? So when you add up every single interior angle, I mean, they're all going to be pretty big angles to make 21 sides. Okay?
Can you try to draw that to the screen?
No, I'm not going to draw a 21-gon.
What's the
That'd be
biggest
super
gun
hard.
you've ever drawn?
All right, number 2. The measure of an interior angle of a regular polygon is 108. Find the number of sides. So if each interior angle is 108 degrees, we want to find the number of sides. So what do we use to represent the number of sides in our formula? N. Okay. So what would be the total sum? If each angle is 108 degrees and we have n sides, what would be the total sum?
108 and 108.
Good. So the sum here would be 108 degrees times n. That would be our sum. So we'd make that equal to 180 times n minus 2. And now, can we get our n alone?
Yes.
Yes, and that would be our number of sides. So how can we get the n alone? Okay, so distribute this. So 108 n is equal to 180 n minus 360. How do I get the n alone now? Subtract the 180 n. So we have negative 72n is equal to negative 360. So then what do we do? Divide by negative 72, so what's your n? 5. So this is 5 sides. 5 sides is otherwise known as a pentagon. Is that okay?
You shouldn't have put these problems so close to each other.
Sorry. Yes.
You done it the other way, so it was positive.
You could have added the 360 and then subtracted the 108n. Yes. Okay, let's look at the next one. The measures of the interior angle of a regular polygon is 135 degrees. Find the number of sides.
So it's the same thing.
So same thing. So tell me, how is this going to be set up?
135 n equals 180 parentheses n minus 2 parentheses.
So 135n equals 180 times n minus 2. Okay, so we would change the 180 times n minus 2. We would distribute that to get 180n minus 360. Subtract 180. Yeah, not divide. Oofda. Okay, so now we have negative 45n is equal to negative 360. 8 sides? So what type of shape? Octagon. Is that okay?
Wouldn't it be negative though?
No, they're both are negative, so when we divide it become positive. All right, ready for some more examples?